In this lecture, we will learn when we build an AI model, we need to know how good or bad it is. We can't just build a model and guess if it works well. We must test it and measure it properly. This is called model evaluation. It tells us how well our model is doing and whether we should use it or improve it. In simple words, model evaluation is the way we check if our machine is making smart decisions or just guessing randomly. Imagine you have built a chatbot. You want to know if it is giving the right replies or not. If you don't check, your chatbot might give wrong answers and users will be unhappy. That is why we evaluate our model. Now, how do we evaluate a model? We use something called metrics. A metric is a number or score that tells us how well the model is performing. Just like you get marks in a test, a model gets a score through a metric. If the score is high, the model is doing well. If it is low, the model needs improvement. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. There are many types of metrics. Let's start with accuracy. Accuracy is the most basic metric. It tells us how many times the model was correct. For example, if we test the model with 100 questions and it answers 90 of them correctly, then the accuracy is 90%. This is easy to understand and very useful when we have clear yes or no types of problems. But accuracy is not always perfect. Sometimes the model may guess right just by chance, especially when the data is not balanced. Let's understand this with an example. Imagine you are building a model to detect if an email is spam or not. If you have 95 emails that are not spam and only 5 that are spam, then your model may just say not spam all the time. It will be right 95 times out of 100, so accuracy will be 95%, but it never catches the spam. This means the model is not useful, even though the accuracy looks good. That is why we also use other metrics. Another useful metric is precision. Precision tells us how many of the positive predictions were actually correct. For example, if the model said 10 emails are spam, but only 6 really are, then precision is 6 out of 10 or 60%. Precision is important when we want to avoid false alarms. If the model keeps saying things are spam when they are not, people will be annoyed. So, a higher precision means the model is careful and usually correct when it says something is spam. Then we have a recall. Recall tells us how many of the actual positive cases the model found. If there are 10 real spam emails and the model only finds 6 of them, then recall is 6 out of 10 or 60%. Recall is important when we want to catch as many true cases as possible. For example, in medical tests, we want to find all sick patients. Missing a sick person is dangerous, so we want high recall in such cases. But what if we want both precision and recall to be good? We use something called F1 score. This is the balance between precision and recall. It gives a single number that tells us how well the model does on both. If precision is high and recall is low, the F1 score will not be high. If both are high, the F1 score will also be high. This helps us when we want a fair view of how well the model is doing overall. Now let's talk about cross-validation. This is a method to test the model in a smart way. Normally, we split our data into two parts, training and testing. We train the model on one part and test it on the other. But sometimes this split is not enough. The results may be lucky or unlucky depending on how we split the data. Cross-validation solves this by testing the model many times with different parts of the data. In the most common type of cross-validation, we split the data into 5 or 10 equal parts. We train the model on 9 parts and test on 1. Then we repeat this by changing the test part each time. At the end, we average all the scores. This gives us a more reliable result. It shows how the model performs on different sets of data, not just one. Cross validation helps reduce the risk of overfitting. Overfitting happens when the model learns the training data too well and cannot perform on new data. It memorizes answers instead of understanding patterns. When we test the model with different parts of data using cross validation, we make sure it is learning properly and not just memorizing. Another advantage of cross validation is that it helps us compare models better. If two models have the same accuracy on one test set, we can use cross validation to see which one performs better across all sets. The model with more stable performance is usually better. In real world projects, we often use cross validation to tune models and make sure they are reliable. It is a simple concept, but very powerful. It is like testing a student with different exam papers to make sure they really understand the subject. Now, when we use metrics and cross validation together, we get a complete picture. Metrics show us the quality of the model's answers. Cross validation shows us how stable and reliable the model is. Together, they help us decide if the model is ready for real world use or not. In Python, there are built in functions to calculate accuracy, precision, recall, F1 score, and cross validation. These tools make it easy to check models, but it is important to understand what each score means and when to use it. We don't just look at the highest number, we think about the problem we are solving. For example, in a chatbot, we care about correct answers. In a hospital, we care about not missing any sick patients. In short, model evaluation is a must when working with AI. It helps us check, compare, and trust our models. Metrics like accuracy, precision, recall, and F1 score tell us how good the answers are. Cross validation helps us test the model on different data and make sure it works well in all cases. Together, these tools help us build smarter, fairer, and more reliable AI systems. So, this is a simple explanation of how we check the performance of an AI model using metrics like accuracy, precision, recall, and F1 score. See you in the next lecture.